Okay, hello class. We are going to talk about the first problem in our sample. Actually, it is final exam sample one. So the problem asks us to find. So actually, it gives us two forces. That is force one and force two acted at acted at a point here. So we are supposed to find the magnitude of the resultant force first. And then the problem asks us to find out the angle between the force one and the resultant force here, and how we can approach that. Well, this actually refers to what we've learned at the very beginning of our class. That is a parallelogram law or triangle rule here, right? Okay, so now we can go ahead to approach that. Okay, so here's the problem. Actually, here's our point O here. And how can we approach that? Well, first the problem asks us to find out the resultant force, right? It asks us to find out the resultant force. Therefore, we need to know what would the resultant vector of the two forces looks like. Well, here actually you can use parallelogram rule or triangle rule. Okay, so both will work. So suppose, for example, we are going to use parallelogram rule here. Okay, then how would the resultant full force be looks like? Okay, so the steps here are actually we are going to form a parallelogram here, right? And the force F1 and F2, they will be respectively the two sides of the parallelogram rule. And we're going to have the parallelogram looks like this, and here is the line that parallel to F1. Actually, it is completely the same as F1. It is equivalent to you directly copy F1 and move to here where you have the tail of the F1 that you copied at the head of F2 here. Okay, so similarly, you can also copy your F2 here. Okay, and since we see that the copy, so the new F2 and old F2, new F1 and old F1, they are parallel, right? Okay, then according to parallelogram rule, then what would the how would the resultant force vector looks like? Well, it will be okay. It will be from where to where? Okay, so it will be from the point at which the two forces are acted at. And that is our point O to where? Okay, it will across the diagonal, right? And to the opposite vertex here. Okay, this right vector here is actually our resultant vector, and we denote it as R. Okay. Well, if you are going to use triangle rule, it will be completely the same. Because if you are going to use triangle rule, okay, I'm going to draw it again. You first have F1 here, right? And F2 here. Well, by triangle rule, it is meaning that you take, so you have the vectors head to the tail, right? And for example, you can take F2 and move F2 such that its tail is at the head of F1, which will make it looks like this, right? Okay, so now I have the new F2 here such that its tail is at the head of F1. And then the resultant vector will be from the tail of my first vector to the head of my last vector here, right? So if you compare the triangle beneath here and the triangle above, you are going to see that they are completely the same, right? Okay, so essentially the parallelogram rule and triangle law, they are completely the same, right? So they can be, of course, as long as you get, as long as you are familiar with one of that, it is completely fine. Okay, so now the question is that how can we find out the magnitude of the resultant force here? Actually, it is the first of our question here. And of course, you are encouraged to think about that, and you can pause the recording for 1 minute here. Okay, welcome back. Okay, so of course, typically how we can approach that is by the law of sine and cosine, right? So it is actually you can find the formulas in the appendix of the exam. Okay, so actually you can now go to the appendix of the exam. And if you go to the appendix in the first page, you are going to see that we have actually at the bottom here we have a bunch of formulas here. It is what you can use. So what you can use here. Of course, it is pretty important that we note what is the correct formula that we have to use here. Okay. Well, I probably should annotate in the document. There it. Okay. So essentially, I mean, those are actually what we are trying to use here. But of course, practice will be needed here to use it correctly. Okay. Okay, so now we move back. Now we move back here. Okay, so for the problem, and we have already drawn here such that we have the parallel. We have the parallel of the two vectors, right? We directly copy the two vectors such that we have them here. And then we have a parallelogram. We have a parallelogram here. So now we can have the resultant to be across the diagonal, right? Okay, so we have our R here. Okay, so now, of course, to use law of sine and law of sines and cosines here, it is pretty important to what? To find a triangle, right? We need to find a triangle such that we can use it. Well, so everybody, can you see a triangle or some triangles in the uh parallelogram here? Of course, right? For example, we can see the triangle ABC here. I'm going to denote it as we can see the triangle A, B, and C, right? Okay, so for this triangle here, and the first, okay, so now we have a triangle here, and we go back to the problem. The problem asks us to find out the magnitude of the resultant force, right? So the magnitude is actually the length of the resultant force here, right? In other words, it is the length of the side of R. And how we can approach that? What law we are going to use here? It is actually law of cosine, right? Law of cosine here, because typically we use law of cosine to find out the length of the side, right? Okay, but to use law of cosine here, what do we need? So we know that by law of cosine, the length, or actually the square of the length of the resultant equals to what? Equals to, okay, first we find out the opposite angle here, call it theta. Then we have R equals to what? R is actually the length of side AB, right? And it is actually square of that equals to what? According to law of cosine. Okay. So we have a to be equals to AC squared plus CB squared, right? AC and CB are the adjacents of the angle theta here. Minus, okay, 2 times the product of the two sides times cosine of sine here, right? Sorry, it is a cosine of theta here. Okay, so now if you look at the formula here, what do we know? We know AC, right? We know AC. It is actually the magnitude of F1. Do we know CB here? Yes, right? Because it is a magnitude of F2 here. Okay, so now what we only don't know here is what is actually theta here, right? But can we find theta out? Okay, so you can think about that here, right? Okay, so theta actually is, since theta is actually the internal angle of the parallelogram, therefore, and another thing is that we also know another internal angle here, which is 30 degrees here, right? Then theta actually equals to, theta will equals to 180 minus 30 degree here. Okay, so if you need me to explain it a little bit, okay, so here we can explain it. So suppose that I extend the line AC and we have, so what would this angle equals to? Since this line and this line, they are parallel, so that will equals to 30 degree here. And theta equals to 180 minus 30 degrees, right? Okay, so now we have theta equals to what? Theta equals to 150. Okay, so now you can plug in everything and you're gonna have R equals to what? Okay, R equals to square root of AC equals to, AC actually here equals to 3, right? AC equals to 3. Okay, CB equals to 6 minus 2 times 3 times 6 times cosine of actually 150 here. That's square root of that. You have it equals to, okay, that would equals to 8.73, right? And be sure to include the unit here, which is actually kilonewton here. And that is actually our answer here. Okay, okay. Okay, so now we've already found out the magnitude of the resultant force here. And now we can move on to the second question here. So the second question is actually asking us to find out what? Determine the angle between F1 and the resultant force here. And where is the angle here? Again, go back to our triangle here. Actually, it is between the F1 and the resultant, right? Actually, if we highlight it, it's gonna be this angle here, right? And if we see that it is alpha. And how we can approach alpha? Okay, so typically we use what to find the angle here? Of course, so rarely sometimes we'll use law of cosines, but typically we use law of sines, right? So we know by law of sines, so the ratio between the length of the side to sine of the opposite angle of, so it will be the same for all the three sides, right? So that means, okay, for example, if I have R here, okay, R is actually the resultant. So, okay, so the length of the side AB or the R divided by sine of what? Okay, divided by sine, I'm sorry, so actually it is divided by, here actually it is better to note that it is a law of sine. Okay, it is a law of sine. Okay, so law of sine is saying that the ratio between the side, so R divided by the opposite angle. What is the opposite angle of the, what is the opposite angle of the side R? It is actually theta here, right? And do we know theta here in the previous question, we've already know that, right? So it is sine of theta, which is actually 50, it is a 150 degrees here. Okay, equals to what? Actually, it equals to the ratio between a side to angle. Okay, given that here we are interested in the angle alpha here, right? So we have alpha here. And what should we have on the actually on the numerator here? It should be the opposite side to the angle alpha, which is actually okay, the opposite to the angle alpha is actually F2 here, right? Okay, F2 here. Okay, now how many equations? Okay, so we have one equation. How many unknowns here? We only have one unknown, right? Because here we know R, right? Here we know R, we know theta, we know F2, right? And then we only so the alpha 1 is the only thing that we don't know. So based on that, we are going to have sin alpha equals to what? It is actually based on the equation here, it will be okay. If we can rearrange that, we're going to have it is F2 times the denominator on the other side divided by the numerator on the other side, right? Okay, so then you can plug in everything that F2 equals to 6 Newton here, and sine theta we've already have in the previous question, which is actually 150 here, right? Divided by R, we know that? Yes, right? So in the previous question here, we already know that. And you are going to find that equals to, okay, the 6 times sine 150 divided by 8.73, it is actually 0.34, right? Okay, so you are going to have alpha equals to what? Inverse of sine. Alpha equals to inverse of sine. And 0.34, right? Which equals to around 19 degrees, right? Okay, so now you can just plug it in here. Okay, it is actually the answer. It is angle between the F1 and the resultant force here. Okay, so this is actually the answer for the first question here.